So this session is one of many sessions as part of the We Do AI 2024 event. It's the first time that this event's been ran. It's ran by the community for the community. There's some great community sessions going on. Definitely take a look to learn more about AI and the Azure ecosystem in general. Some awesome, amazing content by the community. So before we get started, my name is Luke Murray. I'm a Microsoft Azure MVP from New Zealand, here to talk to you about Azure AI Studio. Hopefully I can give you enough information to get going, to have trigger those thought processes around how you might use it to develop your AI applications. Let's get started.
We're witnessing the shift of generative AI. From a niche technology in the hands of a few to an accessible technology businesses are harnessing to benefit the many. Now you can tap into this opportunity to gain an AI advantage, get to market fast, do it right, and do so responsibly, safely, and securely. Copilots are becoming an AI category in and of themselves, and today you can build custom copilots to serve the exact needs of your customers and employees, bringing content generation to all kinds of apps to supercharge creativity, designing contextual experiences that impress and captivate, and freeing people to focus on their highest value work. This is Azure AI Studio, the place to build your copilots, where you can confidently apply the latest state-of-the-art and open source models. Easily ground responses in your data, knowing privacy is protected. Deliver multimodal interactions beyond text alone that feel more natural. And build on a foundation of trust through every step of app development. The possibilities with AI are limitless. Build your own copilots with Azure AI. Let's do generative AI right together.
So hopefully that sets the stage for essentially building your own copilot, using the tools that Microsoft give us to create AI solutions that are responsible, fair, and transparent. But there was a couple of terminologies, acronyms, mentions that people coming from different aspects may not necessarily know. So we'll cover some of the basic terms first, just to make sure everyone's on the same page. So one of the AI terms is really about your prompt. So let's delve into that. So first we have the prompt, which is the text input providing what's expected. For example, extract the email address from the email. The prompt also includes the email as well. So each part of the text is broken down into tokens. We will touch more on tokens later on. And then you have the completion. The output from, which is essentially the output from the large language model. So you've got your prompt, instructing it what you want to do. And in this case, we're also including the prompt, which contains the email as well. So we're grounding it not so much from a third-party system, for example, use your own data, which we'll discuss as part of this session, but more around giving the email within the same prompt and also saying extract the email address. So you're supplying the data you want within the prompt, and that's sending it off to the OpenAI model or the Azure OpenAI model, depending on what you're using there, and that'll come back with the completion. And it does that by breaking down the text into tokens. Because as soon as you start to really pass in a whole bunch of text, you want to be able to break it down, because if you were just to send it all as once, it would all together, it would lose its structure, it would lose its meaning, and you're not getting back those human-like responses that make this technology so powerful. It's really transforming, and they are classed as transformer models behind the scenes. But we'll get more into sort of more information on how they work as part of this session. But I just wanted to really discuss the prompt, the completion, and the token. So we'll delve into those a bit further. So you use the prompts to get the completions from the models. So you can use prompts such as classifying content, generating new content, transforming or translating text, summarizing, answering questions, and really having that chat-like experience. So different prompts can be used to generate various types of completions from the AI models, such as classifying sentiment, generating creative content, translating languages, summarizing text, answering questions, and continuing a given text. So how does that really work? So the tokens can really be thought of pieces of words. So before the API processes the request, the input, so the prompt that you're giving and any information within that, is broken down into tokens. These tokens are not cut up exactly where the words start or end. Tokens can include trailing spaces and even subwords. Here are some helpful rules of thumb for understanding tokens in terms of length. So one token equals 4 characters in English. But one token could also be like a quarter of a word. 100 tokens could be, for example, 75 words. And how the words are split into tokens is also language dependent. So if I was talking to the model in English, the text I would use would be completely different from the text that I would be using in Indian, for example. So it really depends on the language you use versus the tokens that are going in and coming back out again. So models such as GPT 3.5 used in ChatGPT, or previously as part of its original conception and when it became in public, are models trained from specific data sets scraped from publicly accessible information on the internet from a specific point of time. The GPT seen in the tool's various versions such as GPT-2, GPT-3, GPT-4 stands for Generative Pre-trained Transformer. So one of the things I want to really leave you with this slide is it's working with these models and how they process the prompt, break it down into tokens, send it through, and then send it back. It's really just a text calculator making assumptions on what it predicts next, and then doing that again and again and again. And that's what makes these so human-like and easy to understand, because it's essentially the same thing that you would be thinking of, as well as if someone starts discussing a sentence such as, my lazy fox jumped over a, you may think, fence. And that's essentially the same thing that the AI model is doing. It's trying to predict the next word that comes out, or the next tokens that come out. But these models are only one part of the whole chain and the capabilities, and this is where intelligence apps come into play. So the models themselves sit there, you can do API calls directly, prompt, and then get the completion back. However, it's really the intelligent app platform that makes these so powerful. So for example, if we look at this image, we've got the AI services, we've got the AI Studio, we've got machine learning capabilities, and AI Studio really helps you connect source data and across multiple platform services in the Azure ecosystem. For example, you could bring information from Cosmos DB, SQL, Azure Storage, which we'll discuss today, and really integrate it into more production systems. So, for example, you could have Bot Framework running as a Teams app or a chat interface on your website as part of the Azure ecosystem, communicating with these AI models underneath to really give that human like expression and thought. So when you consider intelligent apps and using AI models within your infrastructure in your applications, remember the whole intelligent app ecosystem that Azure provides, from containers through to monitoring, through to like app services for user interfaces and things like that. It's one of the powerful capabilities of this platform is that they're all working together. So let's start to go into Azure AI Studio. So in this session, we're going to talk about the elements that you can use to completely build a custom copilot from scratch at scale. Azure AI Studio is a tool for building custom AI applications. Azure AI Studio brings together best practices and knowledge from Microsoft's own experience with their copilots. You can find AI Studio at ai.azure.com. As of build 2024, this is now generally available. However, there's many different components within AI Studio which still in preview, because as you can imagine, this technology is evolving very rapidly. So although the AI Studio platform is GA, there are elements such as the Assistants API at the time of writing that's currently still in preview. So let's take a look at the Copilot stack and really where AI Studio fits into the mix. So you've got this whole ecosystem around ethical AI. So you've got your safety and security concerns and your content filters. You've got Copilot Studio, which we'll discuss in a second around the differences between Azure AI Studio and Copilot Studio. You've got things like the AI orchestration, which is where AI Studio really comes into play. But it does connect to all these things, such as your own data, the models that it runs into, the underlying AI infrastructure that Microsoft are providing as part of the Azure platform, and really your Microsoft apps and all sorts of other things. So the AI Studio sits really well within the Copilot stack. So comparing two different AI tools such as Azure AI Studio and Copilot Studio, let's take a look at a comparison between them. So Azure AI Studio is a tool designed to provide everything needed to build AI solutions from the ground up, where Copilot Studio is a tool that integrates very nicely with Microsoft 365 and other productivity apps to enhance your day-to-day activities. Azure AI Studio requires the user to build the infrastructure and code, especially around intelligent apps, as we talked about earlier, and the use of AKS and container apps and all those other ecosystem capabilities. But additionally, it also allows you to provide your own training as well and fine tune your models with your own data, especially if you're looking for something that's industry specific, for example, instead of using a generalized model such as a GPT-4o, you may want something more industry specific, such as a healthcare model. And AI Studio allows you to fine tune those. Copilot Studio, however, doesn't require you building infrastructure or coding. It's using the content that's already available in your M365 tenant, such as Power Apps and SharePoint. Azure AI Studio allows users to become experts in a particular subject and provide valuable insights. Copilot Studio primarily focuses on natural language processing and assists knowledge workers in their day-to-day tasks. So Azure AI Studio is really ideal for customizing your AI solutions to your specific needs. especially for custom applications, where Copilot Studio is really best suited for helping knowledge workers in your day-to-day activities, making your workflow more efficient, especially because of that integration with the rest of the M365 suite of products. So while both tools leverage AI, they are not interchangeable and they do serve different purposes. Azure AI Studio is geared towards building your custom AI solutions, where Copilot Studio assists their people into day-to-day tasks. By understanding the distinctions and capabilities of each of these studios, we can better choose the right model for our specific needs. So Azure AI Studio provides everything developers and data scientists need to develop custom copilots and cutting-edge, market-ready, responsible generative AI applications. It's the go-to platform for when you need to create and manage AI projects, develop generative AI applications, explore available AI models, leverage retrieval augmented generation, so that's bringing your own data in, and monitor and evaluate your AI models. And also integrate with the rest of the AI services, as we kind of alluded to earlier with the intelligent apps slide. Azure AI Studio also has responsible AI built in, so it provides guidance and tools to ensure that your applications adhere to ethical standards and best practices. Azure AI Studio is ideal for scenarios where you need a powerful integrated environment to help develop, to deploy, and you'll manage your AI applications. Whether you're extending existing AI solutions or building new ones from scratch, Azure AI Studio provides the necessary tools and resources to help bring your AI products to life. So let's get into really what makes up the AI Studio component. I thought this is worth mentioning because when you start to go into Azure AI Studio, there is differences between your hub versus your project, for example. So let's dive into that before we go into a demo. So an AI hub resource serves as a collaborative environment where teams can share projects, works, models, compute resources, and data connections. It is essential for governing usage and managing various aspects of AI projects. For examples, data upload and artifact storage, scoped connections, compute, security setup and governance. Where a project is more singular, so an AI project groups components for model customization. It orchestrates and provides the tools and customization and isolates data and access to ensure that security and manageability. For example, within projects, you work on your components, so your data sets, your models, your indexes. You incorporate various components such as the data sets, models, indexes, isolated data containers. So it provides a secure container for data isolating from other projects. So you may have a shared hub and then multiple projects connected to that shared hub. And each project is for a specific purpose, a specific team, where you're using shared resources and shared security from an upper hub. So you create your hub and then you create your projects within that. So project scope connections, specific AI services. Yep. And then those projects, that hub connects to connected resources, which the projects use, such as AI search, Azure OpenAI. It provides the model endpoints which your projects can then consume. So let's go into a demo. So we're going to create a project I'm going to show you about the user interface. So I'm going to show you some settings. I'm going to show you some connections, show you the deployments, the playground. I'm going to ask some questions, and then we're going to look at evaluation as well. So how can you evaluate one model versus another? If we click on New Project, it will then allow us to select an existing hub or create a new hub. So remember I sort of discussed you've got your hub, which is the top hierarchy that has a lot of the connections to the Azure AI services that you might be utilizing, and within that hub you have the connection, you have the projects. So we're going to go here under management and select all hubs, and we're going to create one. So there may be, for the purposes of this demo, I'm just going to create a new hub. But if you may have organization requirements, for example, to keep things under private endpoints or within your own VNet or accessible or need to access resources on premises, as an example, you can select the drop-down list and create your hub with customized networking, encryption, identity, dependent resources, or tags. So if you click that button, that will redirect you to the Azure portal, where it'll run through the wizard on how to create an AI hub. You can select your own storage account, your own key vault, you can application insights, container registry, if they already exist, or you can create new ones. But really, one of the options when you're creating an AI hub will be the differences between these three. So for example, by default, if I was to go and connect new hub, which I'm going to do for the purposes of this demonstration anyway, it would be a public hub. So the workspace will be accessible via public endpoint, and then the compute can access public resources as well. And outbound data movement is unrestricted. So essentially, that's going to go outside of the the Azure backbone, and it's publicly accessible. So even though it's worth mentioning that even though alongside all the other Azure services as well, even though the cloud resources may have a public endpoint, doesn't necessarily mean you could do anything with it unless you have the necessary permissions, RBAC roles, SAS tokens, for example. You could also consider private with internet outbound and private with approved outbound as well. So your compute can only access allowed resources and private resources. So for example, if you had more network isolation requirements for your organization, you would most likely be going through and selecting these and creating the private endpoints and setting up the outbound access as well for your workspace, along with encryption if you were using a customer managed key and identity as well. But for the purposes of this demonstration, we're just going to create a new hub. So let's get started. New hub. We're going to specify a name. So for example, we do AI hub. We're going to specify a subscription. I've got 2 subscriptions here. I'm just going to leave that as is. We're going to specify a resource group. So in my example, it's RG Luke AI, and the location. So the location is key because this is a location around your models. So for example, in the demo today, we're going to be using a multi-model model called GPT-4o, and that's available in East US. So I'm based in New Zealand. So usually when I deploy stuff, I'd be deploying to Australia East until the New Zealand North region comes into play. But because I know the model's available in East US, that's what I'm going to select today. We can also stand up Azure AI services or Azure OpenAI endpoint as well, or connect to an already existing one. So I don't have one currently deployed in that region. So we're going to let the Hub wizard interface through Azure AI Studio do that for us. And if we're using Azure AI Search, we can also connect it to that. So for the purposes of the demonstration today and the fact we're going to touch a bit on retrieval augmented generation, we're going to create a new AI search index resource. So let's click on that and then just type in we do AI search. Click on create. That will validate the resources. So for example, it would validate quota. Am I allowed to create the Azure AI search interface? The name doesn't match a resource already with that name, or can I use it? And then once it's validated, we can click next. We can review our settings and then click create. So this is creating our hub, which is essentially our management plane, which we can then create our projects within. And the hub connects things like the AI services, the search, and the storage account, which that we can then consume within our projects. So we'll just give it a minute while that creates that. So it took a few minutes, but now we can see that our hub has been created. So We Do AI Hub has been created. It's currently got no projects, but the connected resources of the hub are Azure AI Search, previously called Cognitive Search, and Azure OpenAI Endpoint, and our AI services. We can see that the users assigned to this hub the We Do AI hub itself, so the hub has got contributor rights within it, and the groups and application permissions as well. So if we go into the Azure portal, we can see that the Azure AI hub exists like any other Azure resource. So it's within the resource group that's been created. The storage account that's been linked to it. We don't currently have an Azure Application Insights, but if we go under Access Control IM, under Role Assignments, we can see that I really need to clean these up. We can assign RBAC roles directly as a normal resource to the hub as well. So give other people access to it. For example, to contributor, I think there's custom roles for AI Hub as well, but let's take a look at that. AI developer and AI enterprise network connection approver. So yeah, that's real. But general AI. So if we go new user, yeah, AI developer, owner, contributor, or reader. So they're the current roles. And so that's the AI developer role there. So we can assign them directly within the Azure portal RBAC interface or directly within the hub itself. If we want to connect other resources, we can just go new connection and we can see we can connect to content safety, AI speech, other AI search indexes, or resources that we may have. So now that we've got our hub created, let's create our project. So we're going to select new project. We're going to give the project a name. So because I'm original, we do AI project, select create a project. So that's creating the project within our hub. This can take a few seconds. So that took about 10-20 seconds, wasn't too long. So the project interface is really we're going to work from now on. So we can see we've got our project overview, we've got our settings for the project as well with connected resources. So we can come in here and connect project level or project scoped resources as well. At the moment, we're just using the connections that were created on the hub. We can see the subscription information, we can delete our project, we can get the API endpoints and keys as well. So we can see here, we can grab those directly if we want to. We can have a look at the models that are available, so the model catalog. But I want to make sure that everything's going. So what we're going to have a look at is deploying GPT-4o. So we're in our model catalog, we're going to select our model, so GPT-4o. We can read about it, we can read the responsible AI considerations, information about the content filtering. But for our purposes, we want a model that's capable of chat completion, so we're going to deploy that so then we can use it. We're going to specify a deployment name, so I'm going to leave it as default GPT-4o. We're going to specify a different version. So these models are iterative, so when a model gets released, so for example GPT-4o, so at the moment the update is May the 13th, 2024, so that's when the model was released for our consumption. It doesn't necessarily mean that that model version will stay the same. There may be updates to the model, there may be things done in the background around jailbreaking or fine tuning or trying to really get the best out of the model. So not only do you have the model, but you've got the versions of that as well. So within AI Studio, we'll just select auto update to default, keep it the same. The model is not available. Maybe because I believe it was global standard. So if we change it to standard, you have your different deployment types as well. So global, global batch, standard, and provision manage. So global standard allows you to deploy to really have a global endpoint where the tokens are shared between different regions. Global batch is mainly around where you want to batch something. So instead of a chat interface where, I don't know, you might be having a chat interface for your shopping website and people are talking into all the time, you may have batch processes where your backend systems may want to create descriptions for products, for example. Instead of doing that live, you can actually batch those up. So at midnight every night, it'll go through, run your process within an hour. You'll get the new product descriptions and done. And so you can get cheaper utilization of these models by batching them all at once. You can also provision managed as well. So this is where you pay for PTUs. So provision throughput units, where essentially you're paying Microsoft for the capacity and performance SLAs as well. So for production systems, I highly recommend this is something that you look at along with the global standard. But for our purposes, we're just going to go with standard. We're going to deploy our model to this OpenAI resource. If we had a custom content filter, for example, depending on what you want to do, you may actually want to allow violence or harmful material, especially if you're working on mental health or something like that. You may have a custom content filter that you can touch on. We'll go into content filters later anyway to have a look at those. and dynamic quota. So dynamic quota is really about taking advantage of available capacity, as it says. So even though my quota tokens per minute, for example, is set to 140k available for my current deployment, there may be times where the underlying GPU resources, for example, aren't getting used. And so Azure will allow you to expand beyond that. If you do dynamic quota, I do recommend you put in place monitoring because your application, especially when you're going into production for these things, because you don't want to become reliant on this. If your application is always going over your quota deployment limits, you either need to raise them or look at how your application is functioning. Relying on dynamic quota, if there's issues or if other people are starting to use the resources at the same time as it's trying to go over and give you that extra capacity, you're going to run into really inconsistent responses. So try to avoid using it if possible, but like for demo purposes, it's fine. So we're just going to click deploy, and that will deploy our GPT-4o model. We can see it's succeeded. It will update the version of the model when the current version expires. We can see the rate limiting we have in here, the tokens, the life cycle status of the model, and the retirement date of the model as well. So that's a year, May the 20th, 2020. We can also see the target endpoint. So for example, this is what we would be doing our API calls against if we were to use a solution such as semantic kernel as an example, or LangChain. We would be able to just look up and run our calls straight to the target endpoint as well. But for our purposes, we're just going to click on chat and we're going to test that the model works. So we're going to select our deployment, which is GPT-4o. Our system message we're going to leave as you are an AI assistant that helps people find information. So the system message helps craft how the model will respond. It's used for things like avoiding jailbreaks. So as an example is you may want to prevent it from doing stuff that you don't want it to do. For example, if you're a shopping cart application, you may not want it to start looking out things or working on things for Azure architecture, as an example. So your system message really helps craft how it responds. We're going to have a look at really looking at this shortly, but for now, I just want to quickly do a quick test of tell me a joke about Microsoft Azure walking into a bar full of copilots. Yep. So Microsoft Azure walks into a bar full of copilots. The bartender looks up and says, "Hey Azure, why don't you take a seat? We've got plenty of cloud coverage here, so no need to worry about downtimes." Gotta love it. Yep, this is why we can't have nice things, because this is what this technology can be used for. Hashtag dad jokes. But this has proven that our model has been deployed. We can now access that model by just typing in our prompt and then getting the completion back through the playground for that. So now that we've tested that, let's start to delve into the system message a bit more. So I'm going to clear my chat and I'm going to add in a system message. So this system message is essentially, you are Will Summers, who served as a court jester for King Henry VIII of England. Your responses should be humorous, witty, entertaining, often using wordplay riddles, and light-hearted mockery. Maintain a jovial and playful tone, incorporating medieval language and cultural references. And then here are our key points to guide your style. So you've within the system prompt, we've given it an identity. So it is Will Summers. We've kind of given it the scope. So he served as a court gesture for King Henry. We've given him how how it should respond. So the responses should be humorous, really entertaining, often using wordplay and riddles. We're also giving it some guidelines as well. So the tone and style of the responses should be speaking with a playful, humorous, and sometimes mischievous tone. Use Old English phrases and medieval expressions where appropriate, and use at least one emoji. Humor and wit, medieval references, role and context, so position yourself as a jester, entertaining in court. Your goal is to amuse and engage using your wit and charm. We've also given it some example prompts. So we're going, what is the weather like today? And the response, for example, is, my liege, the sky is as fickle as a jester's japes. To sort of help give it some context about how we want it to behave and respond. So let's take a look at this. So we're going to put this in here. We're going to apply our changes. We're going to select continue because updating the system message will clear the history of the previous chats if we do have them. Click continue. So now that that system message is in place, we can now test that. So let's do the same prompt that we did previously, which was tell me a joke about Microsoft Azure walking into a bar full of co-pilots. And we can immediately see the response is a lot different. So, a jest about Microsoft Azure and Copilots, you say, well, hold on to thy cod pieces, for here it comes. And there's the emojis, and there's some medieval expressions. So we've changed the way that it behaves a lot. Another thing that you can do, for example, especially when you start giving it an identity to really work with, or persona, we can go, who are you? And it's responded with, why I am Will Summers, the merriest fool in all of King Henry's court. So now that we've taken a look at deploying our model, so GPT-4o, making sure that it works with using our system message and our prompts, how would we go and evaluate our system message and the prompts that we give it again and again and again? So you could use this interface to go through and check and go, oh, that's not quite right, and constantly be updating the system message again and again and again. So update the system message, clear the chat until you get the right behavior that you expect. Or we could go in and go through an evaluation. So if we go into evaluation, let's select manual evaluations. Select new manual evaluation. And here we can see a very similar playground type experience where we've got our model, we've got our max response token, we've got our temperature. So how concise is it? Our frequency penalty. So for example, if it repeats the same thing again and again and again, we will want to give it a penalty so we get more creative responses, as an example. So within this, we could go in and say, let's use the system messages, you as an AI assistant that helps people find information, but let's run some evaluations against that. So one of the prompts I'm going to give it is what is the price of a caramel macchiato at Starbucks? And then I'm going to add another input. What is the price of a caramel macchiato at Starbucks in New Zealand? So let's run these. We can also give it an expected response. So, for example, if you know that the price of a caramel macchiato in Starbucks is $7, you can evaluate against that. So if we click run, we can see the output of those. So the price of, for example, the response, the completion for what is the price of a caramel macchiato at Starbucks can vary depending on your location and any customizations you might have. As of my last update, a tall caramel macchiato costs $4.25 to $4.75 in the United States. However, prices could fluctuate. And then the response to our second, which is what is the price of a caramel macchiato in Starbucks, New Zealand? It doesn't have real-time data access, so it can't provide the current price. Prices can vary according to location. For the most accurate, up-to-date information, I recommend checking the Starbucks New Zealand website, using the mobile app, or visiting a local store. So just adding in geographic data, for example, what is the price of a caramel macchiato in New Zealand, can change the output that you expect. So using the evaluation capabilities of AI Studio can really help you work out, so just upvote or downvote, what you're wanting, what the responses are, and help you really fine tune the prompts that you're using and the behavior that you're expecting to get back from these models. If you were using your own data, you can also bring that in as well. I'll import test data. You can also bring that in as well. So for example, if you actually had like a CSV file with the prices across the US and New Zealand and what a caramel macchiato is, you could bring that data in to test it as well. So this capability is in evaluation. So I did touch on the fact that AI Studio, although it's generally available and for use, there are different capabilities within the studio itself that is still in preview, but doesn't mean that you still can't leverage the evaluation. There is automated evaluation as well. So you can do things like relevance, fluency checks, risk and safety checks as well with an existing data set, or you can use your prompt flow as well. We're not going to touch on that today, but you can do like similarity, sexual content, relevance, run these automated evaluators against your prompts. But I find getting started, manual evaluations is really good to help test the prompts, especially when you're working on an application. You want to make sure that the prompts are giving the right expected outcome. So data is the fuel that powers AI. Garbage in, garbage out. It's important to feed good data into your large language models for quality results. Common issues with customers is poorly formatted and unclean data that can lead to subpar outcomes. With training models, it's super important to have the right chunked data and embedded data. So Microsoft has focused on simplifying the process of connecting your data and formatting it correctly with some of the capabilities and integrations within AI Studio. So Azure AI Studio offers connections to Azure data sources for easy integration. The platform supports data ingestion from on-premises sources and other cloud providers. Azure AI Studio can handle both structured and unstructured data to feed machine learning models. The goal is to ensure that the models receive the necessary information for optimal output. At the heart of it all, the concept of vector search and using vectors for data representation. Vectors are mathematical representations that allow the system to easily compare data for relevant and similar responses. Vectors can vary in their creation and quality. Azure AI Search, which was formerly called Azure Cognitive Search, has support for vectors. Because it just doesn't bring together vectors, it actually brings together vectors and semantic search and classical keyword search as well. So you may hear things about hybrid search, semantic or vector search. What we've found is instead of just using one over the other, so using vector search responses versus semantic or keyword searches, actually integrating a hybrid use case of both semantic and vector search gives you the best quality outcome response completions, getting back from the model using your own data as well. But definitely it depends use case on whether you'd be using the vector versus your keyword use versus keyword or semantic, really based on what you're trying to do and the data that you're trying to collect from it. So let's just dig into vectors a bit more. So think of vectors as a way to represent data using numbers. In simple terms, a vector is a list of numbers. Each number in the list represents a specific feature or characteristic of the data that we're looking at. For example, imagine if you have a list of numbers that represents a fruit. So for example, the color red equals 1, green equals 2, yellow equals 3, the size, small equals 1, medium equals 2, large equals 3, the sweetness of that fruit. So 1 equals sweet, 3 equals very sweet, as an example. If you had an apple, you might it might be represented as 1 because it's a red color, 2 because it's medium in size, and 2 because the sweetness is sweet. So the vector of the apple would be 1, 2, 2 as an example. So I touched a bit on this a couple of slides ago. So we talk about this as vector hybrid search. It actually has had a dramatic positive impact on the results that you're likely to get out of a search index. So Azure AI Studio offers 3 search options: vector search, keyword search, and hybrid search. Vector search excels at understanding user intent and the relationships between the words, but struggles on exact matches. Where keyword search is ideal for finding specific items like product documents, email addresses, or phone numbers, and is fast. Hybrid search combines vector and keyword searches to cater to users' needs, leveraging the strengths of both. Hybrid plus semantic search builds upon the other two and incorporates a semantic ranker to prioritize the most relevant information. So keyword search matches the exact words to search your grounding data. Vector search focuses on conceptual similarity, where the application is using part of the dialogue to retrieve the grounding information. The hybrid approach combines both the keyword and vector searches. Semantic ranking boosts the precision by adding in a re-ranking step that can restore the top results using a larger, deeper learning ranking model. So vectors are to find the most relevant matches before the data is passed back. Vectors can bring out the meaning of a word a lot more, such as like and they and them, and versus your standard keyword search. So really using a combination of hybrid search is giving you the best outcome of both using vectors and keyword searches. Then you can use semantic re-ranking to really adjust the data and re-rank the search results that you're getting back. But again, it really depends on your use cases and what you're wanting to achieve. So make sure as part of your testing within AI Studio that you're really testing each one of these to get the most outcomes. There's no point in going straight for vector searching or hybrid searching if keyword searching, for example, is enough for your use case, because you're adding extra complexity and cost. So when we consider vectorization of your data, what we can do is AI search does is you can bring in data from an Azure blob storage, for example, and it cracks and chunks the data down to individual pieces. So, for example, I believe out of default, it's 1,024 words that AI Studio will do when you start adding in your own data, which we'll go through a demo of shortly. And that chunks that data down and sends it through to Azure AI Search to index that data. So if you upload a PDF, for example, it will break that PDF down into the chunk data, making the search results you're getting a lot more relevant, especially if that PDF document, for example, includes data that you're wanting to get back, but it may be in chapter 1, for example, and split in chapter 4. So breaking that content down really helps get you that relevant results. And a lot of this is done behind the scenes for you automatically. You can fine tune the chunking as well. So you might want from 1,024 words, you may want to chunk it at the end of a page as an example. So you can use things like Python to really adjust how that data is getting chunked down. Again, it really depends on the use case and what you're wanting to do. So definitely have a play with that. You can also do something with AI search around enrichment. So for example, if I was to use JPEG images as an example, by default, AI search will not index those because it's a binary image. But you can use AI enrichment skills in order to do OCR, so optical character recognition, across those images as well, and then bring that into the index. So you've got a lot of functionality to deal with non-text based formats as well. And that will chunk the data and create an index, which you can then read from your web app or Azure AI Studio. So for the purposes of this demo, I've got a PDF document here that's really an extract of the We Do AI 2024 page. So it consists of four actual pages and it's text. So I can select it because it's text. Just note to self for future reference, if you're trying to do PDF documents from a web page, make sure you don't actually go print, because if you were to go and print as a PDF, it will, and then save it. So for example, if you were just, printing to a file as an example, it will be detected as an image. So as we discussed earlier, without the use of AI enrichment capabilities and bringing in OCR over an image, it won't be able to index that data. So just be very careful about the data you're bringing in and make sure it is text-based, an example. Um, yeah, there was an incident that I had a couple of weeks ago where it took me a couple of hours to really troubleshoot what was going on with my index, and that was because I'd actually just printed the PDF documents. So it wasn't able to index them because it was essentially binary pictures underneath, not text. So yeah, word to wise. So I've got this PDF document, and what if I want to ask about it? So in order to do that, let's go back to our Azure AI Studio, and we can go down to data. So we can go to index, and then we can go and create our index and specify a data source. What we're going to do, and do it this way, we could, for example, upload the files directly into the project space. But what we're going to do here is we're going to go to data, and we're going to upload the data, so the PDF document, into a blob container. And then we're going to create an index based on that container. So we're going to go new data. We're going to specify a data source. So for example, I'm going to use the workspace blob store. So this was created as part of setting up the hub. Originally was an Azure blob storage account. If we had the data in another storage account, we could grab the data using the connection string directly as well from things like OneLake, Azure Storage, Blob, even S3. So you can bring in an external connection. But for our purposes, we're just going to select um, our workspace blob storage, and we're going to upload. No, actually, this is not doing what I want it to do. So let's go and add them in manually. I just can't. I think if we upload, yeah, that's not going to do what I think it is. So let's do this. We're going to add it into our storage account manually. So if we go into our AI Hub, where did I put it? Apologies, I'm just trying to check. So it is that count, so 43491, 43491. Let's just go into here and go storage browser, blob, add container, sorry. We do AI 2024. We're going to create a new container. And then within that container, we're going to upload our PDF document. We can see it here. Now, if we go back to our AI Hub, go back to our project, go back to data, select new data. We're going to select, see if that brings in, that's not, where did that come from? 121, nope, that's not it. That must have been, well, let's set this up. Azure Blob. So just for some context, when I went into Azure Artifact Store, or no, Blob Store, The UI path, this is what would happen if you were to upload your data within the AI Studio. So, for example, if we went to upload files and folders, it would copy it into the Azure storage account. So in here, but not in the blob container, it would be in one of these ones. So UI, so there's the version that we inadvertently uploaded using the UI. So you could do it within AI Studio without actually going and creating the blob container and uploading it manually. But for the purposes of this demo, it's really good to just show you what's happening in the background. But so what we're going to do is go and use our custom container that we've stood up, which is the We Do AI one, instead of just going and using the upload file one. So we're going to connect a new service, which is the Azure Blob Storage. We're going to specify our storage account. We're going to specify our container, which is the We Do AI 2024 one that I created earlier. Authentication method. So we can use either credential based or Entra ID based. We're going to use Entra ID based. We're going to specify a connection name. So We Do AI 2024. We're going to set the access to project level. So another project may not have the same connection as example that we do. So, the other containers that the UI path, for example, could be accessible across all the projects within that hub. We're going to select create connection. So we've got an error here. The data store directory couldn't be read. Try entering the storage path manually. Now that is because we specified enter ID credentials to connect. So if we specify view error details, we can see the request is not authorized to perform the operation using this permission. So this is a data plane activity because we're needing to connect to the container and any files within that. So the hub doesn't have the ability to connect to the storage account and the We Do AI 2024 container that we've just created. So in order to do that, we need to set the storage blob data reader role. So let's do that now. So let's navigate to the Azure portal. We're in the resource group that contains our Azure Hub resources. If we go down to our storage account, go to access control, we're going to add role assignment. We're going to specify storage account blob contributor. Which is a data plane action that allows read, write, and delete access to our storage account blob containers and data. We're going to specify next. We're going to assign it to the user account that I'm logged in as. So that's my user account. We're going to specify select. We're going to specify a subscription added for Azure AI Studio data connection access. We're going to specify review and sign, and then set that. That will add the role assignment of storage blob contributor to my account. Now it could take a couple of minutes for RBAC to update and Azure AI Studio to detect that. So we're just going to click refresh for the sake of it, then clicking new data again, specifying our connection. So even though it failed to read the container earlier that we just created, it still created the connection for us. So if we selected that data source, it should, oh, there it goes. It specifies the data source directory could not be read. Try entering the storage account path manually. So we just need to give it some time for the RBAC permissions to come through. So that we'll attempt to get in another minute. So we've given it a minute. Let's give it another go. So new data, select our data source, and now we can see our We Do AI 2024 PDF. So the best thing about what I've just shown you is the fact that AI Hub in Azure AI Studio does not bypass role-based access control that you may be using, especially on things like data. And one of the things we can specify here is really have a think about the access that you may need at a hub level, so shared among multiple projects, to the access that you may need at a project level as well. There may be use cases where you would have multiple hubs, and within that hub, so for example, if you're doing something with finance or HR data, you may not want to risk any leakage of data or permissions across the projects. So in those cases, creating a different hub with dedicated projects for those industry-based elements could be useful. But we can see we've got our data. Let's select that. Select next. We're going to enter in the data source name, which is data. We do AI. We're going to click create. And that's created our data source for us. And within the data source, we can see the total size of the data source is 3.18 megabytes. And there's the PDF document here, including the data connection URI and the name as well. We can also add tags to it. So for example, owner is Luke Murray, which is very handy when you have multiple data sources in place. You can also specify a different version as well. So now that we've got our data source in, let's create an index based on that. So if we go to indexes, we can specify new index. We can specify our data source. So if you've got an existing index, you can connect directly to Azure AI Search. What we're going to do instead is create a new index based on the data in Azure AI Studio. So we're going to select data in AI Studio. We're going to specify our data connection that we've just created earlier, our data component, and then we're going to select next. Now we specify the settings to create the index. So for example, we're going to select our Azure AI Search connection. So this was the AI search instance that was created when we originally stood up our hub. We're going to specify the index name. So we do AI 24. We're going to specify and leave it as auto select. But if you're indexing thousands and hundreds of documents and document types, the index may take a while, but you can specify different compute options here. So for example, you may want a 4-core 28 gigabyte of RAM, 200 gigabyte of storage, standard D12 compute VM and you've got 6 cores available at 39 cents an hour, for example. So depending on what you're wanting to do, you can increase or change the SKU size of the VM that is running your indexing on. So you would pay extra for it, but it could decrease your indexing time as well. So if you start to really think that the index is taking a while, start to have a look at what compute you could be using here. I'm just going to leave mine as auto select, then select next. We can add the vector search, which we're just going to do now. So we're going to select an embedding model, which is the text embedding ADA 002 version, which is pretty standard in order to use because you need the embedding model in order to connect to the data source and create the vectors for you. So this will deploy the model because we haven't already deployed it. And creating a vector embedding will incur a usage on our account. But it's a lot easier to do it as part of this create index phase. And that will automate a lot of the vector index creation on Azure AI search in the background. So we're going to select next. And so this is just verifying that we can deploy the embedding model and we can create the indexes. So for our compute, because we selected auto select, it's just going to use serverless compute. For the demo purposes, I don't really worry if it's going to take 30 minutes, 10 minutes, 5 minutes, an hour. Just leave it as default and then select create. It shouldn't take too long. It should take less than 5 minutes to create this index because it's only one PDF that's 3 MB in size. So that will start chunking our PDF document for us. So I did allude to the fact in the previous that in order to create an index, you have to chunk that data. And Azure AI Studio will do that for us. So now it's allocating our compute resources in order to chunk that data. So what AI Studio is doing is actually connecting to the machine learning instance in the back end. So if we connect to job details, we can see that it's taking us to the machine learning studio and running a custom job for us. So it's found our PDF, our data source, it's found our PDF. It's going to output that document into a chunking and embedding step. And here, yeah, it was 1024 as the chunk size. You can see the embedding model connection endpoint that it's going to use, the ID, the batch size, and the number of workers and verbosity as well. So it's going to grab that, it's going to chunk our data down for us, and then it's going to update our ACS. So it's Azure AI Search. This is just still referencing cognitive search. So it's going to update our AI search for us. And then it's going to create and register our index for vector as well. So this is running in the background, and we can see we should be able to have a look at the job overview, output and logs, enable log streaming, and we can have a look at the execution logs, the standard output, and the error logs as well as that runs through. So it's submitting the run now. You don't need to have a look at that, but yeah, there is also a refresh, and we can see that it started step 1 of 3. While that goes through that process, I'll go back to the Azure portal and I'll click on Overview, and I'll go back to our Azure resource group that has our AI services in there. And I'm going to go to our search service. So this is the We Do AI search. So this was created when we stood up our hub. And within here, we're going to have a look at the indexes. So we can see we've got no indexes at the moment. We're going to look at our indexes. So our indexes is what's going to run to create our index. We're going to have a look at the data sources, and we can see there's nothing in here at the moment, and the skill sets. So this is what I was talking about around optical character recognition and things like that. So we could add in different skills and functions, text, merge, personable identifiable information detection. So these are all the skills that you can add in as part of creating an index. There's the image analysis and OCR skill that I mentioned earlier about bringing in and indexing image-based data. So you can bring a lot of these definitions and these skills to index multiple types of data, and then you could use that within AI Studio as well. But as you can see here, there's no index, there's no indexes yet. That's because this is still running. Where's my cursor gone? There's trouble with multiple screens. There we are. So if we go back to we can see that it's now going through the chunk. And the process is now running. So we're going to give that a couple of minutes, but yeah, we'll just go back to our AI Studio and wait for this to complete. We can see that the chunking has completed, and now it's creating our AI search index. So if we go back to our AI search service and go to indexes and refresh, we should start to see our index. Oh, here we are. Our index has now appeared as we do AI 24, our vector index size, and our total storage size, and document count as well. So if we go into this index, we can see the fields, the content is retrievable. So this is starting to get created from AI Search and Machine Learning Studio. So we'll give that a couple of minutes. It looks like the search service is now completed, and it's now registering our index within, so we can actually use it. We can also go into the index within AI search as well and just do it like a keyword search. So for example, I've just pressed search, and we can see in here that it's going to search for the We Do AI 24 index and grab the context data within that, and we can see some information. So that's been brought in from our PDF document. So the idea of this event is to promote learning and sharing. So we can see that the index is actually working, and it's got data within it as well. And it's completed. So let's actually see if we can query it. So we'll go back to our chat playground again. We're going to use our GPT-4o model. We're going to add our own data. We're going to add in our index. So we're going to select our We Do AI 24 index. That's going to allow us to select the index type. So whether it's semantic, keyword, hybrid, plus semantic, vector, plus keyword, or vector. We're going to leave it as vector plus keyword, and then we're going to ask it, we go a prompt of tell me about We Do AI 2024 and see what that does. And it's come back with We Do AI 2024 is an inaugural event aimed at promoting learning and sharing of knowledge within the Microsoft AI community. The event is scheduled to take place over a single day on Thursday, August the 22nd of 2024, and features various community-driven articles that highlight best practices, lessons learned in addressing some challenging topics in Microsoft AI. So we can see that we've now created our index based on our own data. So in this example, it's just a single PDF document taken from the We Do AI website. And we can now query it using vector and keyword searches within the context of our chat playground. We can see within the references that this is where the completion has come from. Different parts. So this is part 1 of the chunking data, and then part 2. So it's grabbed the information and from the completion back to us based on these 2 references, these 2 chunks of data from the same PDF version, from the same PDF, and as essentially bringer. So one of the best things about these transformer type models is that I've just used tell me about We Do AI 2024 within the English language. What if I want to do it within another language such as Maori? We can run this by doing essentially asking the same question in another language. So let's run that. And we can see that the responses come back within the Maori language. So I didn't specify anything in the system prompt. The model essentially has taken my input and then predicted the next token based on that language. So if we run that through a translator, I'll just run this through Bing Translate. And we can see that it's detected that it's responded in the Maori language, and within English, it's We Do AI 2024 is the first festival that aims to promote learning and sharing. Essentially, almost the same thing. One of the things you can do with your own data, and I haven't tested this, so hopefully it will work, is what are the sessions as part of We Do AI 2024? List them as a table with the speakers as a column. Hopefully it spits out a markdown table. Cool. And here we can see, here is a table listing the sessions and the respective speakers for We Do AI 2024. So I can notice that some of these names are exactly right, and also the name of the session as well. So we've been able to test bringing in our own data. We've been able to test querying it and running different formatting, like being able to go, here's the text, and then format and bring it into to a markdown table, like a table as an example. We've been able to even communicate with it using different languages as well. One thing I do want to quickly touch on is the fact that it stopped. So you may have noticed that it stopped and it hasn't completed the entire table. And that is because within my chat setup, I've got my parameters set, and its max response is currently set to 800. So the reason for that is really about this is the defaults. I can maximize the amount of response that I'm getting. So the token response that I'm getting to, like from 800 to 1800 as an example. and I will get more data back from it. But of course, that leads to extra cost and all sorts of other things. So it wasn't an error that it stopped there. It's just because the max response was still set as 800. If I were to rerun that, change that, and then rerun it again, it should complete that table for me. So just be wary that when you're starting to play around with this, if, for example, you see something very similar to this where it just stops, most likely it will be because of your max response settings. So make sure you take a look at that. Or just completions based on the statistic information on what you're wanting to do. So the different models are tuned and very good at specific tasks. So one size does not fit all. Sometimes you do need a specific model, and sometimes you need the models to be composed within each other so you can get the right result. So you may end up using multiple models in your solution for different tasks. And that's where you can get into multi-agents as well and multi different models to do different things depending on what you wanted to do. But your model selection is very key to really being effective in this space. So GPT 4.0 with Vision, GPT 4 GPT-4 with Vision and GPT-4o are both models that latest OpenAI models that we can consume and use that offer vision and multimodal. So what I mean by multimodal is instead of not only do we deal with things like text, but we can work with images as well. In some scenarios, we can use speech. So these models really can use multiple different elements. And now we've got GPT-4o Mini as well, which just came out a couple of weeks ago as well, which consists of the small language model. So there's really a tight delay of even hours to a day between when OpenAI will release their model and when we can start consuming and using it within the AI studio. So your traditional large language models like GPT-2, GPT-3, and 3.5 are traditionally language-based, text-based. So with the introduction of GPT-4 with Vision and GPT-4o, it's really about multimodal models that go just beyond text, integrating videos and images that can do things like processing videos, answering questions about visual content, summarizing videos. The power of these new models go beyond just incorporating languages and more into visual elements into the conversation as well. So GPT-4o was trained using a single new model end to end across text, vision, and audio, meaning that all the inputs and outputs support video, text, vision, instead of just text outputs as well. So before you may have needed multi different models, or you may have needed specifically trained like form recognizer, AI document intelligence. You may needed whisper models for voice or speech recognition. Now this one model, so for example, in this case, GPT-4o is capable of all of those things, not just text, because it's been trained across all those mediums. So when we talk about ethical AI, we talk about how customers are concerned about handling their own data. So It's something very common in the enterprise environment, and it's really one of the main differences between using open source models or using something like the ChatGPT interface as well, versus consuming AI Studio and hosting the Azure AI models within the Azure platform. So Azure assures that users that their own data, so your own data remains that your own and is not used to train any of the foundational models. So any fine-tuned models that you do completely remains within your own your own subscription and are not visible to Microsoft staff or the Azure platform unless you request it as part of a customer support case, as an example. Microsoft Azure has strong protections for data and data sovereignty. Data is kept secure and remains in the same region, reflecting Microsoft's commitment to data security. So essentially, the exact same controls, enterprise security, data protection controls that you come to expect by hosting stuff within the Azure ecosystem and the data sovereignty rules across, hosting something in Australia versus the US, they're consistent within these models as well. So, and your data. So keep that in mind. Anything that you use. So, for example, we've just been playing around with the chat playground. So, any of the prompts and completions coming back from that is not used to retrain those models again, which makes it really safe to start playing around and using your own organization data in this context. So, we've touched a bit on fine tuning. So, that's really about being able to tune the models where adjusting the system message and adjusting the prompts doesn't quite give you the expected behavior that you want. So 90% of the time, the recommendation is adjust, tweak your system prompt so it behaves the way that you're expecting. There are cases where you may need to fine tune your own models. So recently, Azure AI Studio has announced fine tuning capabilities that you can run on top of GPT for GPT 3.5 Turbo and GPT 4 as well. So you can bring those models and then fine tune on top of those. So let's just go back to retrieval augmented generation versus fine tuning again. So retrieval augmented generation, or RAG for short, allows incorporating data directly into your prompts without retraining the models. So retrieval augmented generation is efficient and cost effective due to its relatively quick process and inexpensive indexing. As we've seen, was very quick to index our PDF document, very fast to retrieve and respond to the prompts about that as well. So internal Microsoft tests have shown that retrieval augmented generation is effective at adding knowledge to your AI experiences, where fine-tuning requires additional compute to adjust the model's weights depending on the expected behavior of what you want. So fine-tuning is used for modifying the tone and format of the AI output, not really for adding knowledge to it. So that's where retrieval augmented generation comes into play. Also, keep in mind your data lifecycle when you're thinking about these things as well. So, you don't want to fine tune your model every single time your data gets updated. So, you may have a backend process running. So, if we go back to the caramel macchiato example that I used earlier in the session, what if that price updates based on the time of year, the time of the month, a special that may be happening? In order to get that expected behavior back, I would need to fine tune that model again and again and again. It's not really intended for that. So fine tuning is really used for modifying the tone and format of your AI output, not for adding the knowledge, which is really where RAG, so the retrieval augmented generation, comes in. Fine-tuning employs low-rank adaptation to integrate the new weights with the base model. So really a layered approach based on what it's done, what's built into the base model already. So both RAG, so retrieval augmented generation, and fine-tuning are complementary technologies. They're not mutually exclusive. And Azure AI Studio offers both RAG and fine-tuning to accommodate your various needs anyway. But general rule of thumb, go RAG, only go fine-tuning if you have that specific use case, or retrieval augmented generation and adjusting the prompts is not really giving you the behavior that you expect. I half expect we're going to see more industry based models as well. So, like GPT-4o and GPT-3 are very generalized based on the information that's been consumed and trained on. I half expect we're going to see like healthcare and retail and utility based models as well, trained specifically on that industry based content. But yeah, it's a very interesting time. So, selecting your model. So, Azure AI, we kind of went through this a bit when we deployed the GPT-4o model, but Azure AI Studio has a model catalog that goes just beyond the OpenAI models. I know I've touched a bit on OpenAI and the models like GPT-4o, GPT-3, GPT-4, but the model catalog brings in a lot more open source models across Hugging Face and all sorts of other things. So you have the ability to deploy and fine tune any model through Microsoft's partnerships within the model catalog, which includes Hugging Face. It really gives you an infrastructure-based approach to integrating your models into those type of models into your own system. The model catalog is a resource where users can select, fine-tune, and deploy the models. So it offers a full experience of integrating open source models into Azure AI for creating generative AI applications. We'll take a very quick demo of the model catalog shortly. Oh yeah, I think that was a duplicate slide, but yeah. There is a new technology as well called Model as a Service, where uh, for customers, so for people looking to not really manage the infrastructure. So Models as a Service allows users to simply call an API endpoint to access those AI models. So the service operates very similar to the Azure OpenAI service, where you deploy an Azure OpenAI service, and then you deploy the models and you get access to consume the endpoints. So Models as a Service really allows you to consume other models, such as Meta and Llama models, through almost a PaaS, so platform as a service interface, where it's you just consume the endpoint and you don't need to worry about hosting and maintaining the version of that model. So other models types offered as part of the model of the service, Mistral, Jace, Cohere, all being integrated into the platform. So it's very convenient for customers to use the AI models without having to worry about the infrastructure management, aiming to simplify the process for customers to integrate AI capabilities into their applications. So testing different models is super important as they perform differently with varying data. So GPT-4, as an example, is an exceptional model excelling in all quality measures, but GPT-4's capabilities may not suit every specific task. So Microsoft AI Studio offers a model benchmarking system. So they're going to start by, and I can show you this shortly, like publishing benchmark results that have run alongside one model versus another, and then gradually expanding out that capability. So future capability might be comparing one model versus another model. within your own environment. The whole concept of Azure AI Studio is really about focusing on providing the tools that you need to simplify your decision making and implement for your own Azure applications, AI applications. So let's go and touch on the Assistance API. So you have many data sources. So you may have something like a database, a search index. How do you orchestrate that all together? And this is where things like the Assistance API can come in handy. So you can do things like ask it a question and it can go and bring back. It can do things like function calling. So, for example, get weather, get the stock market. You can these models aren't necessarily very good at maths, ironically. So, with being able to bring in something like the code interpreter, you can actually get it to do mathematical equations that's using Python as an underlying code base and spit out how it came to that result. So you can use the Assistance API to really help bring in and work with some of those weaknesses that are inherent in the whole ecosystem. And it also has an element of threads, so memory as well. So within the context of the chat playground, when we typed, it's including by default, it was including the past 10 messages within the same prompt as well. So those messages are also brought into your token, affect your token count as well. So assistance, in order to run the similar sort of interface within your own AI application, you need a way of holding the memory of the context of that user. Because if the user types in something, tell me where I can get that from, what does that really mean? When they've just asked, tell me about hiking boots, for example, you want to be able to maintain that context, maintain that memory of that conversation as well. As the Assistance API has that really inbuilt with threads. I'll go through a brief demo. So let's take a look at some of the model benchmarking. We're also going to touch on some of the multimodal aspects, like I talked about earlier, where instead of just working with text, we're going to have a look at some images. And yeah, we're going to also have a look at the Assistance API as well at a very high level and show you what the interface looks like within AI Studio. So let's get started. I'm going to click on Model Catalog. So this is where we went to before to deploy our chat completion GPT-4o model, but I went through it rather quickly in order to get us up and running. So let's just take a closer look. So as I kind of alluded to in the previous slides, there's more than just the Azure OpenAI models. There's the Meta models, so Facebook, there's NVIDIA have their own models, Hugging Face as well. Let's just take a look at those. But each model is very specific in the task that you're wanting to complete with it. So if we have a look at the inference tasks as an example, we can see some of the classifications here around text generation, text classification, translation, question answering, summarization, conversational embeddings, text to speech. So each model within these catalogs is classified. So, for example, if we go and have a look at our GPT-4o model, we can see that it's really good at chat completion. So, essentially, that's exactly what we were doing in the playground. I would prompt it, it would come back with a completion prompt, and we're interfacing and acting with it very similar to how we would with essentially a chat interface. So it's really skilled at doing that, and that's what it gives it that human-like aspect. But these models can do a lot more than just that. If we go through and we have a look, we can see there's models that are really good at generating text. So we want it to do a specific things. We don't really want to behave and work with that model in a way that we're chatting to it completely. We want it just to generate a whole bunch of text for us. Those are models that are really trained in order to do that. So it's really about the instructing. We're instructing it to do something, it's just spitting out and doing that. Mistral, which is open source models for chat completion. We've got text generation. If we have a look at the collection, we can see here. So there's a bunch of Azure AI curated models, which is just everything, I believe. Oh no, except for the Hugging Face. So they're just, let's have a look at that, curated. I think it's picked of the most popular ones in that. Um, Everything apart from Hugging Face, by the looks of it. Yeah, everything apart from Hugging Face. We can have a look at the deployment options. So whether it's just serverless API or managed compute. Really about we can have a look and say we want to do something for text image. We could have a look and see, DALL-E, so DALL-E 2 and DALL-E 3, text to image. So those models are trained specifically on generating images based on text. So we can have a look and go, oh, well, these are the models that we want to use for that. So for example, if we go to our project playground and we click on images, we can see by default, I've got a DALL-E 2 image model deployed. So we could interface that by clicking on sample code and then using the Python or JSON or Go, and it will give us the text code sample that we can just chuck in our OpenAI key and our endpoint. Oh, and we can also connect through here. So this, in order to run our DALL-E 2 model, so text to image, we would go create an image of an ice cream and generate that model. Very similar to the chat playground, but instead of getting text back, we should get an image. So that's been generated based on the DALL-E 2 deployment, and it should come up very soon. And there's our ice creams for us. So that's and we can just copy the prompt that was used to create that. We can generate a new one, download the image, or we can show the code that was used essentially to run and create this. But we may not have known about the use of DALL-E until we'd looked at the model catalog and had a look at the inference task, and we could see what these models are good at and what they're not good at. So that's a model catalog, and we can see, like as alluded to, there's a whole bunch of open source Hugging Face models in here as well, not just the OpenAI models. So if we have a look at the model benchmarks, this is kind of what I was touching on in terms of what if I wanted to choose a model based on question answering? How do I know where to start? Is it based on the reputation of the company? Like, would I go straight for Azure? Would I go straight for OpenAI models hosted by Microsoft, or would I go to a meta model? Like, how do I know where I can start for this kind of thing? And this is where the model benchmarks come in handy, because you can go into here, you want to go, I want to do question answering. I want to select it based on meta only. It will give me like the list of the models, so it's already filtered down to llama models. I can select my data sets that it was trained on, any of the metrics that I really care about, for example, accuracy. And then I can create a list based on that. So I can see the accuracy for GSM 8K. is a lot more higher than the Hella Swag, for example, and I can go back and list that in a graph as well. So it really gives you a good indication of where these models are sitting and what they're used for based on the model benchmarks that have been done against them. And if we click this link, we can see the difference between how the metrics were generated. So accuracy scores are presented at the datasets and the model levels. Fluency measures the language proficiency for a predicted answer, and coherence and GPT similarity as well. So, and embedding benchmarks as well. So it's not just the models, but it's the embedding benchmarks that we can do things like our vector creation and other things with as well. So we can see that the model benchmarks are really, really useful to have. Another thing you can look at is prompt as well. So in our examples within the chat playground, I use the whole Will Summers one as a system level prompt. The default prompt is we are an AI assistant that helps people find information. You can really start to work on your own prompts, especially when you start to develop these for production. And the prompt catalog is a really good place to start. So, for example, if you were a, a real estate agent and you were working on intelligent application that created real estate listings, as an example, based on the images that you supplied these models, where would you start? So if I have a look at the prompt catalog, I can see there's one here for property listing video. We click on that. We can see that one of the starter prompt is describe the property. In this video, and we can see that the system message is given the following images of a residential property, create a compelling and professional real estate listing. So the prompt catalog is a really good place to start when looking at how you can structure your system message. What else was there? It was assistance. So let's dig into the Assistance API. So we can see we've got an Assistant 6.4, so that's the name. We've got instructions. I've changed this interface from the last time I tested it, but you've got your temperature and your top P in your prompt, which is help. You are an AI assistant that helps people find the weather. We can see a new thread has started. We can see that it's still saving. Yep, it's saved. We can add a function, so we can go, what is the weather in the Waikato of New Zealand? And it won't know. So it's a 6 weeks. It's using the same model, so essentially the same GPT-4o that we deployed, but it won't know. So what if you wanted it to actually go and run a function call to grab the weather, for example, or look up the stock price? So what we can do is we can go in here and we can run a function. So we can click add function. And there are some examples here. So the exact same examples I use. So get weather and get stock price. So this won't actually go and work, but it will show you the thinking and the capabilities of this. So if we go and select get weather, and then we go and select get stock price as a function, it's created a new thread for us. So if we ask the same question of what is the weather in Waikato of New Zealand, it will actually understand that you're asking about the weather and mapping to a function that may be relevant. So, for example, instead of just saying, no, I don't know the answer, it would run a function that you could have to actually go and grab that weather, and then it will add it to the prompt and then spit out the completion of that information as well. The same thing as if you were to do things like tell me the stock price of Microsoft. It should know to that. Well, yeah, gotta love it. Sorry, I think I'm having trouble with some rate limiting at the moment, but it should be able to determine the difference between get weather and get stock price, and then run the relevant function according to that. And I think the demo gods are with me today. Let me refresh and start that from the beginning. Yeah, it's kept the same function, so tell me the stock price of Microsoft. We'll wait. And yeah, it knows that actually the stock price prompt is most likely relevant to this function, and then you can call that and bring back the information as well. So the assistance API is really good to start getting going when you're wanting to do things and bring in information, not necessarily through retrieval augmented generation, but data that may be live. So things like weather and stock price and things like that. You want the most up to date information based on that. Code interpreter is another good one where you could go tell me 10 plus 5 and rate limiting. I'll explain how you came to that. And it should spit back the code essentially that was used to explain and work out how the answer of 10 and 5 is 15. Because, like I said, these models aren't necessarily very good at maths. It's not what they were trained to do, but you can bring in code interpreters and other things to really start to give more, I guess, intelligence or capability to what you're trying to do with these, using the models as an underlying base. So that's the assistance API. We've kind of gone through the images, the completions. So I won't go through a demo of this, but I did use the word completion a lot today because completions is really about the output of what's coming, of what these models are bringing back. But instead of a chat interface, completions are more around really like what I've used completions on in the past, except of just chatting to it. What I've done with the completions is I've just used it for summarization. So, for example, instead of a chat sort of interface, I've just gone to a completions model and I've gone, here's the event log from the past 5 days of server running a Hyper-V installation. We've just had this issue. tell me the output of when it started and what the possible cause would be. And so the completions model was able to go through the event log that I'd supplied in the prompt and then output the essentially some of the information in the logs that indicated what the issue would be. If I remember, it was an issue where I was helping someone on Microsoft Q&A, and they deployed an Azure VM wanting to stand up Hyper-V. So they wanted to do nested virtualization, and the VM SKU that they had used was not capable of nested virtualization. And so within the logs, it actually said something about the BIOS or the CPU was not compatible with nested virtualization. So this was able to help me very clearly see that, yeah, there's an issue here. And then in order to run Hyper-V on their Azure VM, they needed to select a different SKU. So completions are like the completion is really good for just do this one thing and get the data summarized back to you. I want to sort of end a bit here on some of the multimodal aspects, just a bit of fun. So I've touched a bit on the fact that like GPT-4o as an example is a multimodal model. So it can do a lot more things other than chat. However, we've just really played around with text. So I've got a couple of examples here that I'll just bring up around, if I find it. Here we are. So this image is a scope of the Azure Hero offerings. So for example, when you're onboarding Microsoft Azure into an environment, it's really about, or looking to move to Azure, it's really about the business strategy. So one of the things when for a successful cloud adoption is having the business strategy, having the support of partners, running the associated discovery and assessments, doing your total cost of ownership and business case and migration plans and blah, blah, blah. So this is about the cloud adoption framework of defining your strategy, your plan, your ready, adopt, and govern and manage. So this is just a GIF image, so you can see it's animated. You can see that it's got a bunch of text about the category of define the strategy, the plan, the ready, the adopt, the govern. You can see the usage management, workload management as an example. So let's take this image, and what we're going to do is I'm going to copy it into my clipboard, and then I'm going to paste it so I can see it here. I can also just attach it if I really wanted to here, but I'm just going to go list image as a table with the relevant sections on a successful migration to Azure. So the prompt is not only list images as a table with the relevant sections on a successful migration to Azure, the prompt is also the image. So what that's done is that's gone in the model, sent that to the model, and the model has immediately gone, here's a table based on the image showing the relevant sections for a successful migration to Azure. So for example, it's already picked up the stages, so define the strategy, and the section, so business strategy, partner support. So if we go back up to here, we can see define strategy, business strategy, partner support. So in the past, you would have needed additional skills. So you might have needed form recognizer or document intelligence in order to do some of this mapping from an image into text and optical character recognition. Now these models are capable of understanding both image and text and converting between them as well. So in this example, we've just really just gone, here's a GIF image. It's got some text in it, put into a table, done. Very, 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 very cool. So another example that I've got here is because I'm based in the Waikato of New Zealand, we've actually got Hobbiton, probably about 30 minutes from where I live. So if you're a Lord of the Rings fan, hopefully you can recognize it. But it looks like a fine day out, nice green, nice paved kind of paths. What can I do here? So I can do the very similar thing by taking this image. I'm going to clear my chat because I don't want anything previously to influence what it's going to output, but I'm going to paste the image into my chat and I'm going to do something like create a half day travel plan based on the image and give me some recommended clothing to wear. So it's gone back to the model and then it's coming back with, based on the image, it looked like you're interested in visiting Hobbiton, a popular tourist destination in New Zealand known for its picturesque hobbit holes and lush green landscapes. So it's detected the image, it's detected what it is, which is Hobbiton, popular tourist destination in New Zealand, and it's also given me a half day travel plan just completely based on this image. So arrive at Shire's Rest, at 9 a.m. You can join a walk-ahead guided tour. You can explore Hobbiton. Midday refreshments at the Green Dragons Inn, and then you're back essentially by 10 p.m. to browse the souvenir shop. And based on the image, it's also given you some recommended clothing, so comfortable walking shoes, lightweight layers, sun protection, waterproof jackets, because the weather can be quite unpredictable in New Zealand, comfortable pants and backpack. So very, very cool, and definitely one of the areas where you can start using these models to just help your daily, day-to-day life. We can also, and it's very hard to demo, and I'm not set up for it currently, but within the chat interface, you can see this little speech icon here. And you can actually, like I talked a bit about video, I talked a bit about text, images. So what about speech? So sorry, sorry. GPT-4o is also speech capable as well because it's a multimodal model. So within the chat playground interface, you can actually enable speech to text and text to speech as well. So if I enable this and then I start talking, I'm not. It'll be interesting to see how this works with the recording. So let's give it a go. Testing, 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 testing. Oh, we can see that the chat playground has successfully converted my speech to text. So there's an accessibility feature for you there. If we go back to the slides. So Microsoft has had these principles for a while about how we can approach and think about safe and responsible AI. It's one of the reasons that originally early on you had to fill out a form to kind of get access along with capacity management. It was understanding why you wanted to move it, why you wanted to request access to the OpenAI service. And for example, when you were starting to do things with vision as an example as well, you needed to prove that you weren't doing things that were not quite ethical, especially because everyone has a mobile phone these days. You can take pictures, and then all of a sudden you've got your pictures or your video, and you're wanting to do stuff around facial recognition of people that you may not have the rights to do, or mess around with that. So, AI principles and responsible AI is huge. And there's six principles that really we should start to think about when you're looking at architecting and working with AI models. Fairness. So AI systems should treat all people fairly. How might an AI system allocate opportunities, resources, or information in ways that are fair to use to the humans that use it? There's a certain amount of bias with these models. Keep in mind that the information is trained on access to the internet, which is primarily Western based information. Not all humans, not all countries have the full extent of access to the internet and the ability to upload content and add to the content of the internet that a lot of other companies and organizations and geographic regions do. And that inherently brings in a bias towards that data as well. The more information about a subject or more information about a country, the more likely these models will respond in a certain way based on that. So really think about the fairness of what you're trying to use these AI systems for and how can they allocate and work with humans in a way that's fair to everyone accessing these systems, no matter where they're coming from and what they're trying to achieve. So reliability and safety. So AI systems should perform reliable and safely. So how might the system function well for people across different use from different conditions and contexts, including the ones it wasn't originally intended for? So think about really how the system is going to be safe and reliable for what you're wanting to use it for, and make sure it doesn't go outside of the principles of that, and make sure it's safe. It's got safety guards in place to prevent it from doing things that it shouldn't be doing. Privacy and security along the same lines, so AI systems should be secure and respect the privacy. How might the system be designed to support that privacy and security? So, inclusiveness. So, AI systems should empower everyone, engage people. So, think about how might the system be designed to be inclusive of people of all abilities. So, like Braille versus text versus English versus other languages versus the way people need to interact with these computing systems. Just think about how you can be quite inclusive in your design of AI based systems. Transparency, this is a big one. So, AI systems should be understandable. How might people misunderstand, misuse, or incorrectly estimate the capabilities of the system? How has it come to the conclusion that it has? Can you explain it? Can you understand it? Is it transparent on why it's answering the way that it's answering? Can you back that up? Something to consider. Accountability. So people should be accountable for the AI systems. So how can we create oversight so that humans can be accountable and in control? So a very common example of this one is there's was an airline that started using an AI chatbot, and all of a sudden it started to give out vouchers. So people got half price, potentially a lot cheaper flights based on the AI controls. Who was really accountable for that? How could it have been understood in the terms and conditions, in in the accountability of what it was trying to do? Make sure you have really clear, responsible, accountable ownership of these solutions as well, and make sure you're continuously reiterating over each of these principles over the course and duration of the life cycle of your project. But the thing is, it's not just the principles. The principles infuse engineering processes, the way that we build things, from everything from how we source data to how we train and from how we train the models. But there's research, so cutting edge thought leadership going in, privacy, governance, enablement, customer signals, so customer success, engineering, sales, partners. All of these aspects and different functions really work with and as part of the principles. Azure Content Safety really works a lot on some of the responsibility aspects. So Content Safety is a new addition to Azure AI Studio. It's been used internally by Microsoft for the Copilot products and now available for use within AI Studio. It's capable of identifying hate speech, sexual content, jailbreak attempts, so attempts to do things with the model that's not necessarily supposed to do. The Content Safety Service is designed to help maintain safe digital environments. It's another tool that's offered through the evaluation features on the AI dashboard within the AI Studio. The evaluation tool helps identify data biases and issues with production application. These tools are part of a strategy for building safe and secure systems. So, we touched a bit on evaluation earlier on with the manual evaluation of the system prompts and the prompts that we were giving the solution. But there's a lot more capability within the ecosystem of AI Studio around evaluating your content safety, evaluating your use of responsible AI and content safety filters as well. So make sure you check those out. If you're still listening to me ramble on, we're almost there. Thank you for being a part of it. Hopefully you've learned something. This is taking up a lot more time than I thought, but I'm trying to give you a full experience that you can kind of understand where some of the capabilities of this product suite. So the last thing we'll touch on is really about the full development life cycle. So I've showed you a lot of playground-based stuff, but what about looking at moving from day zero to day one, so more production orientated. So let's take a look at some of those capabilities. So the development life cycle is not just about calling the API and walking away. There's quite a lot of bit of engineering that goes into shaping your prompt, that goes into orchestrating the model, how the APIs are called, and how do you do that? So you need a complete way of doing and testing those type of functions. One of the things you can look at is something called Prompt Studio, which is generally available as part of the AI Studio suite. So it's a tool that's used internally by Microsoft, and they offer it out as well for a tool that we can consume as users. So it's a tool for prompt orchestration, for evaluation, and prompt engineering. It's deeply integrated into AI Studio and also into the AI machine learning suite of products as well. In fact, it uses a lot of the machine learning studio that we saw when it was earlier on, when it was attempting to create our index. The prompt flow is really built into that as well. So some of the tools, again, evaluation really gives you the behavior of understanding what things are doing with what. So evaluation is a huge part. This slide is actually in the wrong place, but apologies for that. But yeah, so there is some future capabilities of AI Studio coming. You might have already heard about Windows AI Studio. So it's really about being able to extend AI Studio to the edge by simplifying AI app development on local Windows devices. So Copilot for PCs has just come out. So the latest capability of personal computers that have an NPU, so neural processing unit, actually built in, running small language models directly on your own personal computer. So we're going to see not only a wave of intelligent applications start to appear around the internet, but locally intelligent applications running on your local devices as well. So look out for Windows AI Studio capabilities into AI Studio. And there is a VS Code extension for this if you're interested in it. There is an AKS link as well. We're not going to delve into this any like within this video, but it's worth calling out. So the last demo I want to give is really around prompt flow. And in the interest of time, I don't have anything prepared directly with this. However, there is a really good tutorial online, and I'll bring that up. So this is prompt flow right here within the AI Studio. And we can create our own flow. So one of the really good examples that I'll put in the chat is being able to bring in and query across multiple indexes. So in our examples, we've gone what is about AI, we do AI 2024, what are the sessions that are running, blah, blah, blah. But what if you wanted to do a comparison between we do AI 2024 versus another event like Microsoft Build? Like what is here versus what is not here as an example. To do that, you may have two different indexes, one for the we do AI 2024 and another for Microsoft Build or Ignite when that source data are in there. You can use prompt flow to bring in both those indexes using Python and bring back your completed prompt. There's a good tutorial online on how to do that with hiking shoes, and then bringing in a customer index and then the product index and then merging those so you get the prompt on what did this person buy the last time as an example. But within the AI Studio, you can see here we've got prompt flow, create. We've got example prompts on how does it actually run the Q&A on our own data. What if we wanted to create a chatbot that leverages Wikipedia to help ground the responses? So we can view the information about these. We can create our own custom one, or we can see that it's using Python and we can clone it and really start to develop our prompt for read access to the storage account, folder name already exists. What has it done? I'll need to look at my permissions again, but I think there is some really good videos online by Seth, who's done quite a lot of good videos on prompt flow. I will put the link to those in the video. It's not worth me going through when he's done such a really good job of discussing them. But hiking, trail, boots, prompt flow, mess line. This one. I will do one more thing. Tutorial, tutorial. Is that the exact same one that I ran? Yes, it is. Yeah, I'll put this in the chat. But hopefully that's given you a really good understanding of some of the capabilities of AI Studio, where to get started from selecting your first model through to developing your system prompt and the way you interact through to it. I just want to leave you with some resources to learn more. So Microsoft Learn has some really good material around building AI skills. There's applied skills. You can join an AI community on Discord as well. So come in and join us, have a chat, ask questions. Got some Microsoft Cloud advocates in there, and there's also a Microsoft Learning Guide as well. So a lot of great links to get started. But thank you for listening to me today. Hopefully you've learned something. Make sure you check out all the great content coming up on the We Do AI 24 sessions. There's some great, amazing topics. But yeah, have fun, learn. Let me know how you get on. Thank you.